Welcome to this section, Interacting with our Data. In this section, we'll learn about reading items by implementing the read command, creating items with the add command, deleting items with the remove command, updating items with the update command, displaying our to-do list with the list command, and some other commands including info and init. At the end of this, we'll have our working to-do list application. Welcome to this video, Reading Items. In this video, we'll look at reading items by implementing the view command. So here's our editor, and here's our main function from before. We can open the embedded terminal, and we'll build this program. We'll then run the program using the info command, stack exec for this. It displays the to-do list. You'll see in the main function it also writes the to-do list out to the default data path in this case. Let's look at the contents of that file. On Windows, this will be under the user profile. On Windows, this will be under the user profile environment variable as .to-do.yaml. We'll use the type command. On Linux and Mac, we can use the cat command, and it'll be in the home directory, $home. We can see we have some well-formed YAML. Now, let's remove the test code from the main function. Follow this code here. And we'll re-enable the run function invocation here. Let's take a look at the view command. This is the implementation here, the run function. Currently just calls put_strlen with the string view and outputs the index. We can run this command in our build loop in our terminal. This is build. Disable optimization, sit in a loop and watch file changes, and execute this command, to do exe view 0. We can force a rebuild by changing the file and saving it. We can see it successfully emits view index equals 0 to the terminal, which is this implementation here. So our task in this video is to implement the view case in the pattern match, and we'll replace the expression on the right hand side, which I have highlighted here, with an evaluation of our view item function. The view item will take the data path and the index. At the bottom of the file, we'll write a stub for that. View item takes file path, item index, and yields an IO action of unit. Appropriate stub will be view item equals undefined. We'll save. Here we go. We see it attempts to evaluate undefined and crashes the program. So now let's implement view item. Here's the basic implementation. We use our existing readToDoList function, which we have defined up here. It takes a file path and yields an IO action of to-do list. And then we're going to do a pattern match on the to-do list constructor in order to extract the items data from it. And we'll save. We can see from the output here, it is printing the list of items to the terminal as we'd expect. So now let's index into the list. Now typically we'll do indexing into lists in Haskell using the bang bang operator. And this is defined in Prelude and has type list of A to index to an A. At first blush this seems perfectly reasonable. Take a list of A and an integer index and yield the A. However, we need to be able to handle the case where the integer can be out of range, less than 0 or greater than the number of elements in the list, -1. And so we're going to use an alternative version of bang bang, and this can be found in the list safe package. So we'll go and add that to our Cabal file. We'll save that. And stack tells us that the plan construction failed, and this is because list safe 0101 is not found in the LTS 7.8 snapshot that we're using by default. But it does helpfully tell us that we can force it pull the package from package by adding an extra depth section. So let's do that in our stack.yaml file. Here we go. Extra depths, dash, and list save dash 0.1.0.1. We'll save again. And now Stack is able to find the list save package and successfully builds the project. Great. Let's go back to our source file. Now in list save, we have bang bang, and this has type list of A to int to maybe A, where the operator will return nothing if the index is out of range. In order to gain access to this, we'll need to add an import to the top of our source file. So let's do that. We'll import data.list.safe, and we'll just import bang bang for now. This is how you import an operator with special characters in its name. You surround it with parentheses. Now, since this will collide with the built-in prelude function of the same name, we need to hide that. So we'll add another import. And this import here hides the bang bang operator that's exposed from the prelude. Let's go back to our view item function at the bottom of the source file. We'll introduce a let binding. This will evaluate the index operator with items and IDX as its operands and return a maybe item. And we can now use a case expression to pattern match on that. We can handle the nothing case where the index is out of range. Output a helpful message instead of just crashing. Case that there is just an item, we can pattern match. For now we'll just print the item. We'll rebuild. We now see it is writing out just a single item from the data file, which is presumably the one at the 0th index. It's great. Let's make it a little bit prettier though. So instead of print item, we'll write a new function, show item. This will take the index and the item, and I'll provide an implementation of that up here. So show item takes the item index, the item, and returns a IO of unit action. This argument list will use the item data constructor to pattern match on the properties of the item, the title, and description priority and due by, the last three of which are all maybes. We use putstr with strings constructed from these values. IDX is an int, so we need to call show on it to get a string. For MB description, MB priority, and MB due by, we're going to use this helper function, show field. This takes a function that we're going to apply to the argument, MB description in this case, if it happens to be just as opposed to nothing. And the same for priority, we're going to apply show to it. For due by, we're going to use this format time function. This will output the date in a pretty format like that. And this is the implementation of the show field function. It takes a function from A to string, which is ID, show, and the format time expression here, and a maybe of A, which are these arguments here. And in the case of the field being nothing, we'll return not set. Otherwise, we'll apply F to X and return that. So open our terminal and save. And here we are. This is the pretty version of the output. Here's the index, here's the title, and we've got description, priority, and due by laid out more neatly. So at this point we're done, and we can now view individual to-do list items.